Now in this lecture we will study DMA controller and IC name is 8257. This is the 40 pin Intel IC. DMA stands for Direct Memory Access. It is used to transfer the data at fastest rate. It allows the device to transfer the data directly to or from memory without any interference of CPU. Now, actually, if data should be transferred from the I/O devices to the memory, now if this is a microprocessor, I/O device, I/O device and memory. So now if the data transfer should be done means what? Through the microprocessor it is required means what? Microprocessor has to fetch the opcode from the memory, and after decoding it, executing it, and it will read the location, and after that it will write or read the data into memory or into the I/O devices. For that what it will take so many number of clock cycles. Thereby what? The data transfer is slow. So to avoid that, we are using the DMA, so which will transfer the data directly from the I/O devices to the memory. Here, the data transfer directly, it will happen by using the DMA. DMA is connected to the I/O device. So it will transfer the data directly between memory and I/O. Now if you see, this is the 8085 microprocessor. This is the DMA 8257, DMA 8257, and I/O device is connected to the DMA. Here I am showing the single I/O device. So whenever the I/O device, now in a 8085 we have a two pins. One is a hold and another one is a hold acknowledgement. HLDA, hold acknowledgement pin. By using these pins, DMA is connected to the 8085 to these two pins. Now, whenever the I/O device want to transfer the data, first it will send the DMA request signal to the DMA. So in response to this, the DMA will send the hold request signal to the hold pin of the 8085. Now in this DMA, hold request is there. This pin is connected to the hold pin of the 8085. Now what is the meaning of this hold request? DMA is asking the bus control. So thereby the DMA can transfer the data from between the I/O and memory. So in response to this hold request, so processor will load the address. In the address register, it will load the address, and in the counter register, it will load the number of words should be, how many number of words should be transferred. That value is, that number is loaded in the count register. And after loading the address and count value, then it will send the hold acknowledgement signal to the DMA. So what is the meaning of this, the hold acknowledgement? Now the 8085 is giving the control on control to the DMA, bus control to the DMA. Thereby what? DMA owns the bus mastership, and now the DMA is the master. So after receiving the hold acknowledgement, DMA will send the DMA acknowledgement signal to the I/O device. So after that, it will transfer the data between the I/O and memory. Now this is the sequence of operations performed by a DMA. Now we will see the few features of DMA. Now here the DMA 8257 is a 40 pin IC which is having the 4 channels. Means what? 4 I/O devices can be connected to a single DMA controller, and each channel is having the 16-bit address register and 14-bit counter register to store the address and count value in these registers. Now each channel can transfer the data up to 64 kilobyte, and each channel can be programmed independently. And each channel can perform read transfer, write transfer, and verify transfer. And after every 128 byte transfer, then it will generate the mark signal. And here it requires a single phase clock, and the frequency of clock is 250 Hz to 3 megahertz. And it operates in 2 modes. One is a master mode and another one is a slave mode. Now here we will see the block diagram of 8257. As we have studied, the 8257 is having the 4 channels. Here you can see channel 0, channel 1, channel 2, channel 3. This is the internal internal bus. To this bus, now these 4 channels are connected. And if you see in this channel, each channel is having the 16-bit address register and 14-bit count register. And each channel is having the DMA request signal and DMA acknowledgement signal. For channel 0, DRQ0, and channel 1, DRQ1, like that. So 4 different data DMA request signals are pins are there. Now for this, so the IO device is connected. Now this is the channel device 1. This is the device 2. Like that, what for 4 channels, 4 devices can be connected. Now if any one of the device want to transfer the data, it will generate the DRQ signal. In response to this DRQ signal, DMA will send the HRQ signal to the HOLD signal will send to the HOLD of the 8085. So now here, if more than one devices are wanted to transfer the data and it generated the DMA request, then here priority resolver can resolve the issue and it will select one channel and DMA will serve that channel. So now here 2 types of priorities are there. One is a fixed priority and another one is a rotate priority. Fixed priority means what? Channel 0 is having the highest priority and channel 3 is having the lowest priority. So whichever is having the highest priority, the device which is connected to the highest priority channel, so always the DMA will give the first preference to that channel. So thereby what the least priority channel, the device which is connected to the least priority channel may not get the choice to transfer the data. For that, what we can choose the rotate priority. Rotate priority means what? Here the priority levels will rotate. Which channel is served recently, that channel attains the lowest priority. Now, for example, this channel 1 is served. Now, if it is this channel 1 is served by the 8257, then the channel 1 attains the lowest priority. So this is the rotate priority. This priority can be resolved by using the priority resolver. Now coming to the data bus buffer. Now this bidirectional bus is connected to the data bus buffer, and here microprocessor will send the data by using this. Now here this data bus is connected to the microprocessor. Now microprocessor will send the data by using this bus to the data bus buffer first, and after that the data will be loaded into the address register and channel count register, and also microprocessor will write the modes. Now here one more register is there, that is a mode set register. In that register it will write the 8-bit value in this register. So for that this data bus is used. Now once after attaining the mastership, the 8257 will transfer the data from the IO device to the memory by using this data bus. Now here this data bus is now, because 8257 is now master, it has to generate the address. That address is what? How many address? 16 address. 16-bit address, that is A0 to A15. Now if I write this, now here A0 to A7 is the lower order address and A8 to A15 is the higher order address. Now this higher order address lines are time multiplexed with this data bus. And coming to the read write logic. Now here IO read, IO write, clock, reset, and A0 to A3 address lines. So now if you see IO read bidirectional and IO write is also bidirectional. Why bidirectional means what? Whenever the microprocessor want to write the data and want to read the data, that time processor will send the IO read and IO write signals to this DMA. Means what? Inside If microprocessor want to write the address and want to write the count value or want to read the status of this channel, here status register is there. It is a 8-bit register. So it will give the status of this 8257. If the processor want to read the status of this 8257, then it will read the data by sending the read signal. So inside this arrow mark means what? Processor is giving the read write signal to the DMA. And if outside means what? If the DMA want to read the data, write the data from the IO devices, then it will give the IO read and IO write. So DMA give these signal. That's why bidirectional control signals are here. And a clock is means what? So here this is using the clock to transfer the data. For every clock, it will transfer one word. Now reset. If 1 bit is applied over here means what? It will reset or it will clear the channel registers. Now here address register, counter register. If it is holding any value, if we wanted to clear that value by giving the reset signal, it will clear the these channel data. Now coming to the A0 to A3. Here also it is a bidirectional. If it is inverse means what? So if the microprocessor want to write the data or want to read the status, that time what? If microprocessor is accessing the registers which are inside the 8257. To access these registers, it needs some address. Those addresses are given by using the A0 to A3. So now here 4 address lines are used. So means what? 2 to the power of means what? 16 registers can be accessed. Now for example here only one address bit is there, A0 bit is there. So by setting this 0 and 1, only 2 registers can be accessed. If I am taking A0 and A1 2, so 2 to the power of 2 address lines is equal to 4. Means what? 4 registers can be accessed. Now 2 to the power of 3 address lines. If A0, A1, A2, 3 address lines are taken, so 2 to the power of 3 means what? 8 registers can be accessed. Now here if you see, each channel is having the 2 register. Now here it is 8 and status register is 1 and one more mode set register is there. So total here 10 registers are there. So more than 8 registers are needed to access. That's why we need to take the 4 address lines. So those 4 address lines are what? A0 to A3. Inside means what? It is microprocessor is accessing the registers inside the 8257. If it is outward means what? Already we have discussed that 8257 is a master. After receiving the HLDA, it is a master. So it has to generate the address. In that address, upper higher order address bits are time multiplexed with the data. Means what? This bus itself is acting like a data bus and a address bus. Now coming to these A0 through A3 is the lower nibble of the lower order address. Now here this. Now chip select is enabling the complete this chip. Thereby it can read and write the data. Now coming to the control and mode set logic. Here if you see outward address bits are there. A4 to A7 means what? 8257 generated these 4 address bits. Now here total 16 address bits are required. So 8 bits are time multiplexed with this data and 4 bits are generated over here. 4 more bits are generated here. So thereby what? Total 16 address is generated by the 8257. Now coming to the ready. Now here 4 IO devices are connected. If any IO device is slow to transfer the data, so it will send the 0. If it is by sending the 0 means what? 8257 has to wait to transfer the data. It will go into wait mode. Now when that device is ready, then it will send the 1, thereby what? 8257 will transfer the data. Now HREQ means what? Whenever any IO device is requesting for the transfer, that time it will send the HREQ means what? Hold request to the 828085. So HOLD is connected to the request signal. Now here this request is going to the HOLD. In response to that, so processor will send the acknowledgement signal to the DMA. And memory read and memory write means what? Whenever the DMA want to access the memory to read and write, that time it will send these memory read and memory write signals. Now coming to the address enable and address strobe. By using these two, it will processor will separate the data line and higher order. Now, what I said, this higher order address lines are time multiplexed with this data. So, by using these two, it is separating these address lines with the data lines. Now, these signals are applied to the latch. No latch. Now, here this latch is enabled by using the address enable, and by giving this strobe signal, it is separating the address and data buses. Now, coming to the terminal count. Now, terminal count is indicating the present DMA cycle to the present peripheral device here. Now, coming to the mark, after every 128 byte transfer, so mark bit will be generated. Now, this is about the functional block diagram.